You know, our planet isn't just some static ball of rock floating in space. It's this incredibly dynamic, heat-driven system. We're talking moving oceans, a shifting crust, and a history that's, well, deeper than you can imagine. In this explainer, we're going to take a whirlwind tour of the very forces that shape our world.
All right, so we've got 4 major stops on our journey today. We'll kick things off with the massive engine that drives our seas, then we'll plunge deep into the solid Earth itself. After that, we'll uncover some secret reservoirs of water, and we'll finish up by learning how to read the epic stories told by the rocks themselves. Okay, first up, the restless ocean. Now, it covers over 70% of our planet, but it is far from being just a big, calm pool of water. No way. It's a massive, powerful engine that is constantly, relentlessly in motion.
So what's the deal? What's actually making this enormous global ocean move? It's not just one thing. Turns out it's this huge collaboration of forces, all working together across the entire planet. The best way to think about it is like this massive, complex dance. It's a choreography where temperature, the saltiness of the water, and the wind all have these leading roles, moving incredible amounts of water over thousands and thousands of kilometers.
What's really fascinating is how all these things interact. So you've got temperature and salt creating differences in density. Colder, saltier water is heavier, right? So it sinks. Warmer, fresher water rises. That alone creates a global conveyor belt of water. Then at the same time, you have wind pushing the surface, but the Earth's rotation bends that movement. That's the Coriolis effect, creating these huge circular currents. And then on top of all that, you have these massive, slow-moving planetary waves that transfer energy across entire oceans. It's a whole lot going on.
And believe me, this has a huge impact on the real world. This whole system can create phenomena like El Niño, where just a shift in the Pacific Ocean's temperature can trigger droughts in Australia, completely mess with the fishing industries in South America, and totally alter weather patterns all across North America. It's just a powerful reminder of how connected everything on our planet really is.
That same planetary heat engine that's messing with the oceans, it has an even bigger effect on the ground beneath them. So, let's leave the water's surface and dive deeper, right through the seafloor itself, to explore the incredible mechanics of the solid Earth.
For the longest time, the whole idea that continents could actually move was just dismissed. The real game changer, the aha moment, was the realization that it wasn't the continents plowing through the sea. No, the entire ocean floor was moving, like a giant conveyor belt, just carrying the continents along for the ride.
So how does this whole conveyor belt system even work? Well, it all starts at these mid-ocean ridges, where magma from the hot mantle rises up and forms new crust. As it cools, it actually records the direction of the Earth's magnetic field at that time. And since the field flips every now and then, it creates this perfect, symmetric, striped magnetic pattern on either side of the ridge. That was the smoking gun for seafloor spreading. This new crust pushes the older rock away until it finally gets recycled back into the mantle at these deep ocean trenches.
But what's actually powering this massive movement? Well, one of the main engines is something called slab pull. As that old, cold, heavy edge of a tectonic plate sinks back into the mantle at a trench, its own weight literally pulls the rest of the plate along with it. I love this analogy. It's just like a heavy blanket sliding off the edge of a bed.
Okay, so mapping the ocean floor is one thing, but how in the world do we know what's thousands of kilometers beneath our feet? I mean, we can't drill there, so how do we see the unseeable?
The answer, and this is just incredible, comes from earthquakes. This slide actually shows an old exam question, and the clue is right there in that phrase, shadow zone. That's a place where certain waves from an earthquake just mysteriously disappear.
And here's the big reveal, the key to the whole puzzle. You see, there are different types of seismic waves. P waves can travel through pretty much anything, solids, liquids. But S waves, they cannot travel through liquid. And scientists started noticing that after a big earthquake, S waves just weren't being picked up on the other side of the planet. There was this huge shadow. The only possible explanation? They were being blocked by a massive liquid layer deep inside the Earth. And that's how we discovered our liquid outer core.
Okay, let's travel back up from the planet's core, way up into the crust, because those same tectonic forces that move whole continents around, they also crack and shape the rock right beneath us, creating these massive underground storage tanks for a resource we all need, but almost never see, groundwater.
This slide really gives you a sense of the sheer scale of our groundwater use.
Now, I know this is a lot of numbers, but just let your eyes drift over to that irrigation column. The numbers for states like California and Texas they're just enormous. They tell a really powerful story about where our water is actually going. In fact, if you add it all up, the fresh groundwater used just for irrigation across the U.S. comes out to 49,000 million gallons every single day. That is an almost unimaginable amount of water being pulled out from under the ground, mostly to grow our food.
So, where is all this water hiding? Well, it's stored in these underground layers of rock or sediment called aquifers. As you can kind of see here, you can have an unconfined one, where the water table can rise and fall, or you can have a confined one, which is trapped between layers that don't let water through, which keeps it under pressure.
All right, for our final stop on this whirlwind tour, we're going to become time travelers. We're shifting from the Earth's processes happening right now to its incredibly deep past. Because all of these systems, the oceans, the moving plates, the flow of water, they all leave their mark. And we're going to learn how geologists read the planet's history, a story that's written in stone.
The whole idea here is to stop thinking of rocks as just, well, rocks. They're not. They're archives. They are history books that have recorded absolutely immense tectonic forces, changing climates, and the entire history of life on Earth.
I mean, look at this. Under unimaginable heat and pressure over millions and millions of years, solid rock can actually bend and fold like it's clay. It creates these incredible structures, like the one you see here. And geologists can read these folds to understand the insane forces that have shaped a region, telling a story of deformation that happened ages ago.
But it's not all about brute force and immense pressure. The rock record is also this incredibly delicate archive, preserving the absolute finest details of creatures that lived hundreds of millions of years ago.
Just look at the detail here. On the left, that's a cross-section of a single coral from about 400 million years ago. On the right, a whole fossilized colony. It's absolutely breathtaking. These aren't just fossils, they are literal windows into ancient oceans. And get this, these little organisms don't just record their own lives, they record massive geological processes. It was actually Charles Darwin who first figured this out. A coral reef starts as a fringing reef right around a volcanic island. As that island slowly sinks over eons, the coral keeps growing upwards, creating a barrier reef, and eventually the island vanishes completely, leaving behind only a circular ring of coral, an atoll. It's this epic story told over millions of years by tiny, tiny organisms. So, we've gone from swirling oceans to a liquid core, from hidden water deep underground to the fossilized ghosts of ancient life. It really makes you wonder, doesn't it? As you go about your day, what other incredible stories of force, of time, and of life are locked away in the rocks right beneath your feet,